In this session, we're going to learn something called a law of sines. Okay, what it says is this: if you have a triangle A, B, C, we use the capital letter to show the angle, and then we use the lowercase letter to show the side. So this is a little a, little b, and a little c. All right, now the law of sines says this: A over sine A equals B over sine B equals C over sine C. Okay, so it's kind of like easy to remember that. If you want to prove, it's fairly simple. So let me make this a C little flat, and here is A, and this is the angle B. If you drop down this, the height at the base, so here's a B, and here is the angle A. You can tell that this H, when here's a 90 degree, this H is actually A multiplied by sine B equals little b multiplied by sine A. See that? Okay, because we already learned the right triangle trigonometry. And then this is equivalent to that because both sides, if you divide it by sine A and sine B together, so you're going to get A over and the sine B canceled out with that. So you have sine A at the bottom, and then the other side you have B over sine B. Okay, and this, because A, B, C, we just say A, B, C. You can also say A, B, C. It doesn't matter about the order. Therefore, you kind of like proved the law of sines. It looks really nice, isn't it? Okay, and for this one, it doesn't really matter whether, as before, we have the right triangle or we have this oblique triangle. The oblique triangle, which means you have the triangle, there's no angle equals 90 degrees. So it could be this, okay, or it doesn't matter which one, but as long as there's no angle that's 90 degree, we call this is the oblique triangle. All right, so this is how we proved it. And then the next one, we're going to say, how do we use it? When we use the law of sines, you can tell we have a side, angle, angle, angle. Okay, so if you know some sides, or you know some angle or angles, then you can find all the rest. So every time when I ask you to solve a triangle, which means I need you to find what is A, what is B, what is C, and what is a little a, what is a little b, and what is a little c. So this answer, that's the solution of a triangle. All right, now let me give you one quick example here. We have a triangle ABC. So we go, this is A, this is B, this is C, and I know here is 82 degree, and here is a 64 degree. What else do I know? I know this little c is a 14 centimeter. All right. Now this is a side angle. So this is the SAA type. Okay. By this order. So side angle. Or you can say angle side. It's the same as AAS. So two angles you already know. And you know one side. So if I ask you to solve for this triangle, first of all, if you have a 2A, you're in very good shape because we know the sum of the interior angles of this any triangle is 180 degree. So which means A plus B plus C is 180 degree. But we already know 2. So we know A 64 degree and a B we don't know. But a C I know 82 degree, and that is 180 degrees. So this is a very, very simple equation. I just need to go ahead and solve it. So I can get my B is 34 degree, which means you're going to use 180 minus 82 minus 64, so you get a 34 degree. Very good. Okay, so I have this 34 degree. I know three angles in this law of sines. I have an angle, angle, angle. I know one side, so of course I would be able to find the other two sides, right? Okay. Therefore, I have A over sine A equals B over sine B equals C over sine C. This is law of sines. All right, now I don't know A, I don't know B, but I know little c. So my A over, the good thing is I know the angle. So angle A 64 degree, which is B, I don't know, but I know the angle B. I just found it. Equals C is 14 centimeter. So all the answer later you get is going to be in centimeter. And this is a sine 82 degree. All right, now once you have this equation, you can just cover this, use this tool, you can find A, right? Because A will be just this side multiplied by sine 64. So I know my A is going to be 14 centimeter over sine 82 degree multiplied by sine 64 degree. If you have the calculator, you will get the answer is 12.7 centimeter. All right, and this little b, I need to cover that. So b will be this guy multiplied by sine 34. So that's a 14 centimeter over sine 82 degree multiplied by sine 34 degree. And again, use the calculator, you get a 7.9 centimeter. So when I ask you to solve the equation, I would always, for me, it's my habit, I always write my answer like this. My A is 64, little b, capital B is 34, and my C is 82, and the little a is 12.7 centimeter, little b 7.9 centimeter, and C as given 14 centimeter. So this is my solution to a triangle. Okay, now this is the SAA type or AAS type. It doesn't really matter whether you talk about the S first or you talk about the S at the end. But the good thing is if you have a 2A, then you can find the third A. You have two angles, then you should be able to find the third angle. And then you go ahead and use the law of sines. All right, now let me ask you a quick question. If I give you this side, angle, angle, is this triangle fixed? Okay, let me change the question into another one. If I give you side, if I give you angle, 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 if I give you A type, let's see, I give you 45 degree, 90 degree, and a 45 degree. Do you think that triangle is going to be fixed? So we know that we're going to have a triangle look like this, right? So 45, 45, and 90. And also you can have this, isn't it? 45, 45, 90. So if I give you three angles, that triangle is not going to be fixed, which means given angle, 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 you're not able to solve this triangle. But if I give you 2A, 1S, or SAA, then yes, that triangle is fixed. Just like you get the two angles and you can find the third angle and you have one side, then you use the law of sines. All right, now this is the example. Let me give you another one. Also the triangle. I have to solve the triangle. That looks like this. Okay, so this is B, this is A, this is a C, All right, now I don't know little a, but I know here is a 40 degree, and I know this is 22.5 degree. Uh, and I know this, I know B equals 12. So what is this? This is an angle, side, angle. So that is angle, side, angle. Yeah, angle, side, angle. Okay, we can also do that because I know 2A. So I will be able to find the third angle. Therefore, the A plus B plus C is 180. That's what I know. And therefore, my B is going to be 180 degree minus A minus C. So that's 180 minus 40 degree, then minus 22.5 degree. So the answer is 117.5 degree. So this is a 117.5 degree. That's my angle B. All right, now I know one side. See, I have two angles, so I should be able to find the third angle. Once you have three angles known, and if you know only one side, you will be able to find the rest of the two, which is the A over sine A, law of sine, that which we just learned. B over sine B equals C over sine C. All right, now I don't know A and C, so I put A over sine A is 40 degree. And for B, a good thing is I know B. Okay. And so this example, they didn't tell you the whether it's in centimeter or in meter. It doesn't really matter. It's just 12. It's the measure. It's the length of that side B. And then the sine angle B, which we just found it out, 117.5. And then C, little c, I don't know, but I know the angle C, 22.5. Okay, so it's going to be very, very similar to what we did earlier. See, for the first two parts, they're equal. There's an equation. You solve for A, multiply by 40 degree both sides. So my A equals 12 over sine 117.5 multiplied by sine 40 degree, and it's roughly 8.7. I usually, for the length, I keep one decimal places, and for the angle, most of the time I will just keep the whole number. All right, unless the given 22.5, then this is 117.5. All right, now the C will be this guy. You multiply by sine 22.5 by that, so it's 12 over sine 117.5 degree. Multiply by sine 22.5 degree. And if you use calculator, you get the little c is roughly 5.2. Okay, so I know A is a 40 degree. I know B is 117.5 degree. And I know the C angle 22.5. And my little a is 8.7. My little b is 12. My little c is 5.2. I solved this triangle. All right, now you know all the sides and all the angles, and you might want to see for the greater angle is corresponding to the longest side. Okay, the smallest angle is corresponding to the shortest side. That's what I ask you to know. All right, now we learned this. Given two angle and one side, I don't care whether the side is next to one angle, next to the two angles, or between two angles. We know how to solve that. All right, now the next one is what about this? What about give you two side and one angle? Side, side, angle. Okay, so side, let's see, there's a triangle here. Okay, so this is A, and I don't know where, and that's B, and there should be C. Okay, so side, see, I give you C, all right, and then I give you A. I try to solve it. And this A, there's going to be several situations. Now, first of all, I ask you to drop that point B or form a 90-degree. Let me call this as H. All right. Okay. Now, what if you are given this angle A, right? This is the angle, and then side, side, right? Side, side, by that order. So if your A is exactly the same as your A is exactly the same as C times sine A. If A is exactly the same as the height, so that means you're going to form a 90-degree triangle. This is right triangle. So there's going to be one solution. Okay, that angle C should be 90 degree. And then you can go ahead and solve it because you already know A. Okay, so you have C and then you can go ahead and solve it. So this is the first situation if A is exactly equal to H, and that H is C times sine A. Okay, that's the first situation. The second one, what about if A is less than C times sine A? If A is shorter than H, then the problem is, I know this angle and here is the C, and here I know the side is here. I just don't know how long is that. But my A, just like what I'm drawing here, my A, the side is too short. It would not be able to touch this. Therefore, there's no solution. You can tell this side A is too short. It won't touch it. Okay, next, what happened if A is longer than H, is longer than H, which is little c times sine A, which is longer than this. So let's say this long. So see, you might be able to create two solutions, isn't it? Yeah. So that means this is the situation that you can have. That could be the side A and side A. Here is A. Sorry, here is B. You see that? So the length of this side A, it can form two triangles. One is this. One is ABC. The other, oh, we call that C1, and this is C2. It could be ABC2. Interesting, huh? However, this A must be shorter than C. Why? Because this A, you spin that and you're going to get two solutions, but it cannot go beyond C. So if A is greater than C, which means if this side A is too long, it's longer than that. If it's longer than that, then there's only one solution because there's a C, there's A. It's going to be like that. That's your A. Because A is longer than C, then there's only one solution. All right, now this case, it will have two solutions. Okay, and here's one solution, two solution, no solution, one solution. So it's all varies if you are given S as A. If you're given two sides, and then next to that you have an angle. So this angle is not in the middle. Okay, in the middle we're going to deal with that later in the next session. Okay, so if you understand that, let's look at this question. I ask you to solve a triangle given this. A is 50 degree, Little a is 10, and b is 20. Can you solve it? So this is, if you draw A, B, C, it doesn't matter about the order. So A, B, C, if you do that. So what is known? This is a 50 degree, and A is 10, and B is 20. So this is a very typical SSA question, right? That's the ambiguous question. So it might have a zero solution, it might have one solution, or it might have two solutions. So let's look at this. Okay, I have this. Let me just get a 50 degree first. So this is a given, and this B equals 20, and this is the point C. And then I have the A is like half, it's only 10, right? The A is only 10, so the side A is like a half of this side. Therefore, it's going to be about this level, right? So what do you think? It doesn't look like it's going to touch that. So let's see. If you draw a vertical line here, this is the H. So my H equals B times sine A, which is 20 times sine 50. And that is 15.3. So from here to here is a 15.3. But if your side A is only 10, it won't be able to touch it. So therefore, there's no solution. Okay, so you see the tricky part is you just draw an ABC and then mark what you know, and then you have a better idea what you should do next. If you think I have A, I have A, I have a B, I have a lot of signs, right? So I know this A over sine A should be the same as B over sine B. Can I do that? Try to see what happened. My A is 10, sine A, which is 50, and my B is 20, and that's sine B. And you said, hey, I have all those three parts. The only thing I don't know is B. Let's go ahead and find it. So if you go ahead and solve it, that's cross multiplications. You have 10 times sine B equals 20 times sine 50, and then divided by 10 both sides. So your sine B equals, I already know 20 times the sine 50, which is a 15.3, divided by 10, I get a 1.53. What do you think? Sine B, you get a number greater than 1, which is impossible, right? Because for the sine function, the domain, the range has to be between positive and a negative 1. So from here, you can tell there's no solution. Okay? You get exactly the same answer. All right, now let's try another one. I give you A equals 35 degree, and I give you little a is 12, and I give you little b is 16. Again, we have A is 35, so I know this A is 35 degree, and A is the side here, and this is the B equals 16, so this should be C. All right, now again, I drop this. Let me find out what is H. It's 16 times sine 35 degree, and that is 9.177. All right, so this is 9.177, but your A is 12. See, the 12 is greater than this H, because 12 is greater than 9 point something. So, and also it's shorter than 16. So you're going to have two solutions. Okay, so one is this. Here is the 16, B is the 16, my A is the 35. One solution is this. So I have here, my A is 12, here's the C, here's the B. This is one. All right. Another one is that the other side. Here's a 16, here's a 35 degree, and then that is A is 12. See? Interesting, right? All right. Now, what are you going to do now? Let's see. I can use the law of sine. And use the law of sine. Let's try to find this one first, because this B is acute angle, which is less than 90 degrees. So I know A over sine A equals B over sine B. Therefore, 12 over sine 35 degree equals 16 over sine B. All right, now very similar. I cross multiply, then divided by 12. So my sine B equals 16 times sine 35 degree divided by 12, which is 0.7648. Okay, now once you know the sine B is this, you can use calculator to take the inverse function. If you do that, the B1, this is B1, and this is B2, okay? So B1 is going to be sine inverse of 0.7648, so that is going to be 50 degree. All right, now did you notice the relationship between these two? This is a B1, this is a B2. And you remember that we have, where was my last page? Here. You remember how do I get these two angles? And this is A. So this angle and this angle must be the same, right? So if you have two solutions, this is your first solution, and then this is your second solution. So see, this is the same as this one, and this add up to that is 180. So if you have one solution, the second solution will be 180 minus that. So if you have B1 is a 50, then your B2 is going to be 180 minus 50, and that is 130. And you know the two angles, if they add up to 180, then they have exactly the same sine function value, which means sine 50 is the same as the sine 130, right? So we know A, we know B, and then we can find a C. So we know A is 35. So my C1 is going to be 180 minus A minus B1, which is 180 minus a 35 degree minus a 50 degree. And that is going to be 95 degrees. So I know little B1, I know the angle B1 and the C1. So this is 95, and here is a 50. See? Pretty good, huh? And then I have a B1, B2. So my C2 is going to be 180 minus A minus B2. Those are like the two sets, so we got to work them separately. So it's 180 minus 35 minus 130, and that answer is a 15 degrees. So here is a 15 degree. All right. Now, once you know the three angles, and you also know two sides, you only need to find the side C. So A over sine A is C over sine C, so which means 12 over sine 35 degree, which is the same as C over, and that's your C2, so it's a sine 15 degree. All right, so that's also the little c2, because this is C and this is C, they're very different. Okay, so you multiply by sine 15 degrees, so I can get my C2, little c2. The length of side C2 is 12 over sine 35 degree multiplied by sine 15 degree. Okay, so that is the very short one, is 5.4. Very good. So I get a little c equals 5.4. Similar to this one. And A, which is 12 over sine 35, equals this time the C2, sorry, C1, sorry, this is C1 over, and that is the sine 95 degree. Right, so my little C1 will be 12 over sine 35 degree multiplied by sine 95 degree. So that answer of my C2 is 20.8. So here the C equals 20.8. Did you see that? I don't have space, I didn't write it. So you can give me the two solutions. You have the side A, side B, the angle A, angle B. Here is 130 degree. Okay, angle A, angle B, angle C, side A, side B, side C, angle A, angle B, angle C, and a side A, side B, and side C. So for this situation given, you actually have two solutions. So that is the law of sine. I think once you know this, you're pretty good about that. All right, now let me give you a real interesting example, and it's related to something called a bearing. And do you know how to read this? North 49 degree west. When you draw the map, so this is the north, and here's the south, and this is east, and this is west, right? That's usually that's how you show the direction. North 49 degree west, which means north, 49 degree west. So that goes to, and this angle is a 49 degree. It shows the direction. So this is the bearing of this direction. All right, now here is, let's see, there's a real situation. There is a and a B, these two. This the fire lookout stations. Fire lookout stations, and they're 13 miles apart. All right, so people here and the people here, they know they're 13 miles apart, and A is directly to the west of B. So that's why I put them in this direction. So this is west, this is west, this is on the east side. Now, both stations right now, they spot a fire. So let's see, there's a fire here. Okay, so here's a fire. All right, and then when they look at the fire, if you are standing here at this observation station, you see the fire. Do you know the distance? Usually you don't, right? But you can tell the bearing, which means you can tell this angle. So this angle is north 35 degree east. So you're going to report, say, hey, I spot a fire, and that is north 35 degree east. So you're telling people the direction. And this guy said, yes, I found one. I found it too. And this bearing is north 49 degree west, right? North 49 degree west. Now, the question, how far is the fire from station B? Let's change this point. Let's call this as a C. It become a triangle. All right. And this north and the east form a 90 degree. So if you know here is a 35 degree, you should be able to find out this angle. So here's the 35. This is going to be 90 minus the 35. So that would be 55. And very similar to here, if this is north 49 degree west, so this angle is 49, subtract that from 90, so you get this angle should be 41 degree. What do you know? You know angle, angle. Hey, you have two angles. Can you find this one? Yes, of course. Let's do that before we forget. So C will be 180 degree minus 55 degree minus 41 degree. You can do that, right? So that would be 84 degree. Let me just write it here. Here's 84 degree. And I'm looking for this. Basically, I'm looking for what is side A. But I know this. This is a 13 miles. And in my triangle, this is side C. I know angle. I'm looking for that. So I only need to say A over sine A equals C over sine C. I don't need to worry about that because they didn't ask me that. All right, now A is what we don't know. So A over sine 55 degree equals 13 miles over sine C, which is sine 84 degree. And you can find A because you multiply by sine 55 degree both sides. Therefore, my A equals 13 times sine 55 over sine 84 degree. Okay, so you get a 10.7 miles. Sounds good? This is the distance between the fire lookout station B to the actual fire. So once, let's say you are working in one of these, once you hear the report of the direction, then you can use this. This is the law of sine to get the distance. And as a practice, you might be able to also find the distance between A and C. Why I care about this? Because this is shorter angle, smaller angle. I know this should be shorter, but they just ask for it. So once you find the distance between the fire and the observation or lookout station A, that distance is supposed to be smaller, so it should be shorter than 10.7. All right. Now, a little bit of extra things I want to talk about is to find the area of triangle. Okay. A, B, C. This is H, and this is C, A, and B. And we know the area long time ago is base times the height over 2 or times 1/2. So in this case, my base is a C, and the height, this H, is actually B sine A. All right, so let me just write it in a better way. So my area equals 1/2 BC sine A. Equivalent is going to be 1/2 AC sine B, or 1/2 AB sine C. This is just a little extra. I'm not going to give you examples, but that's something I think it's good to know. And it's not really hard. Once you have the picture here, you can just see it. So this is the law of sines. And in next session, we're going to learn law of cosine.